Okay, welcome to the third and final video for this section, right, for salts, okay? And this is the last section where we are going to do the final tests for cations. Okay? We're also going to do a slight revision for anions, right, at the end of this, right? So basically, this is the most, well, students find this the most confusing area when we are talking about the final test and confirmatory test that we need to do, right? So in actuality, it's not really that complicated. Yes, a bit of memorizing, but if you really break it down into smaller segments and look at it in one by one, right, basis without getting overwhelmed, it's actually not very confusing. So that's what we're going to do. Pay close attention, right? I hope you're fresh and not too sleepy or anything, right? Absorb whatever we're going to do right now, and you will really you'll really see that actually this chapter is not as hard as it seems. Okay, all right. Okay, but it needs you to really focus and concentrate and be at your best game for this. Okay, so let's go. The test for cations, guys, right? So we're going to do this. Please pay attention. Okay, so number one. The cations usually that we test for will be aluminium, lead, zinc, magnesium, calcium, iron 2, iron 3, copper 2, and ammonium ions, right? So these are the normal cations that we test for because this is the most common, right? Cations. Number two. So whenever we want to test these cations, in number two, they're telling you we will always test it in the form of an aqueous cation solution. It's always an aqueous solution. You cannot do the tests if you have solid powder or anything, right? No, right? So if you have it in solid form, what do you need to do? You have to make it in aqueous form. So if it is so it depends what salt it is, right? If it's a soluble salt, all you have to do is just dissolve it in water. That's one method of preparing the aqueous solution. Okay, if it's not a soluble salt, then you can't use method A. We will go to method 2B, where they will say you take the salt, you dissolve it in a dilute acid, okay, and then you filter it, you remove the residue, you collect the filtrate, and your filtrate is the aqueous salt solution. For anyone who felt confused, right? So now I have in my container here, okay, insoluble salt, right? So what do? I take that, okay, now I mix it. First step I do is I mix it with an acid, right? Okay, so now it mixes with an acid, right? And I take the whole thing and I filter it. Okay, when I filter it, I will get residue, okay, and a filtrate. This residue I don't want, right? This filtrate is what you're going to keep, and we're going to consider this your aqueous cation solution, right? So it's very simple. If it's soluble salt, what do? Just dissolve in water, right? If it's insoluble salt, then what do? You add acid, then you filter, and then you keep the what? You keep the filtrate, okay? That has your aqueous cation solution. So basically as simple as that. Okay, so this basically you just have to know whether it is a soluble salt or insoluble salt. So that's it. But the main point that we are talking about here, right, is the fact that whenever doing any of these tests for cations, we are going to need an aqueous solution, right? And if it's a soluble salt, we will use method A. If it's an insoluble salt, you will use method B. Okay, all right, either way you will get an aqueous salt cation solution. When I say cation, okay, when I say cation, it just means it doesn't mean that the solution only has cations. No, it's a salt solution. There's cations and anions, but since we're testing for cations, we're only bothered about the cations present. Okay, so aqueous solution has both, right? It even has anions, but right now we're looking at from the point of view of cations, so that's why I'm going to call it a cation solution, right? Okay, let's move on to number 3. Pay close attention. Now that we have our aqueous cation solution, we can start doing the tests on it, right? So number 3, the aqueous cation solution is then tested, right? We're going to test it with sodium hydroxide solution, okay? Then we're going to test it with aqueous ammonia solution, right? And finally, to do some confirmatory test, we will use a specific reagent that is special, right? If it's iron 2, we will use one type of chemical, which is called a reagent. If it's iron 3, we'll use a different chemical reagent. If it's ammonium ions, we'll use a different reagent to test it. So that one is very specific, right? It depends what anions we believe are present. So first we need to narrow it down, and then only we'll go to C, right, where we use a specific reagent. But otherwise we will follow method 3A and 3B. That is the beginning process where we start narrowing everything down. So the best to do is to use sodium hydroxide and ammonia solution, because both of them can give off produce or contribute hydroxide ions to your original salt solution, right? So please go to number 4, and we're going to see what they're going to say about that. Number 4, sodium hydroxide and aqueous ammonia, right, which is what we're talking about here, right, A and B. So sodium hydroxide and aqueous ammonia will give the hydroxide ions to produce metal hydroxide as precipitate with cation solutions, except for sodium, potassium and ammonium, right? Okay, so as you know, okay, so now here we have a particular metal, right? Okay, so we have a solution, let's say lead nitrate. Okay, so we have lead nitrate here. So if I mix it with maybe sodium hydroxide, right, it will form lead hydroxide and sodium nitrate. This lead hydroxide will be a precipitate, and normally most of the time it is a white precipitate. Okay, so that's what they're telling. So what is happening here? Why are we mixing sodium hydroxide? We want the hydroxide ions to react with the metal ion to produce a metal hydroxide, which will form a precipitate, right? So basically all we want, why we're adding sodium hydroxide, is just to start this process, okay, to give in or to contribute the hydroxide ions, okay? All right, then why would we use ammonia? Well, let's do the same thing, lead nitrate. Okay, now we add in ammonia, and then they also said when we add ammonia inside, right, again ammonia is going to give the hydroxide ions. You might now question, hey, sodium hydroxide, it was very clear, right? It is sodium hydroxide there, it can contribute its hydroxide ions. Where's the hydroxide in ammonia? Well, guys, right, if you're wondering that, well, when you mix ammonia with water, you dissolve it in water, what you're going to get is, okay, two things. One hydrogen from here will go here, and you will get ammonium ions, NH4 positive, right? The balance, right, balance, there's one O and one H here, right, will be what? OH negative, right? So basically when you dissolve ammonia in water, right, we say aqueous ammonia, right? So aqueous ammonia is already mixed with water. So actually what do you have? You will have ammonium hydroxide. So yes, or when you add ammonia, there is hydroxide ions, and these hydroxide ions will go and mix with the lead, okay, and it'll form what? Lead hydroxide, okay, and it's also going to form what? Ammonium nitrate, okay, so NH4NO3. See, so that is what is going to happen, right? So don't get confused when you see the products and you're like, hey, wait a minute, where did the oxygen come from, and so on and so forth, right? Okay, or hydroxide, where did the hydroxide come from? Okay, it actually is coming from aqueous ammonia solution, because aqueous ammonia produces ammonium and hydroxide ions. So either way, whether we are mixing it with sodium hydroxide or aqueous ammonia, both are hydroxide ion providers, so that we can form metal hydroxides, which will form precipitate. In this case, again, it's a white precipitate because it's lead hydroxide. Okay, so I hope you're able to absorb this and understand what is happening. All right, okay, now let's move on. Okay, where was I? Yes, right, okay, so that is what is happening. However, so you basically, when we add sodium hydroxide or ammonia, it will form metal precipitates, right? So the metal precipitates that what? Are white in color most of the time, or it could be a colored precipitate if it's a transition ion, okay, if the cation is a transition element ion, right? However, if it is the cations we're testing is sodium, potassium, or ammonium, they are all soluble ions, right? So it will form soluble salts. So only for sodium, potassium, and ammonium hydroxide, there will be no precipitate formed. Okay, any other hydroxide, there will be a precipitate form, most of the time white, and in special cases where it's transition elements, it will form a colored precipitate, which we're going to see now, right? Okay, don't worry, we will be summarizing this as we go, right? So let's go to number 5. Transition element cations produce specific colored metal hydroxides, whereas all others which are not transition element based are definitely going to produce a white color precipitate. Like I told you, lead hydroxide, definitely white color, right? Okay, so what are the colored cations? Well, the same usual suspects, right? In this case, if it is a blue precipitate, it's probably copper hydroxide. In other words, there is copper 2 ions, like that. Okay, no big deal. Actually, dirty green precipitate, then it's Fe2 positive ions. Okay, so again, if you add ammonia or aqueous ammonia or sodium hydroxide solution to a copper salt solution, it will form a blue precipitate, because copper 2 is blue, will form a blue color precipitate. Copper 2 hydroxide is a blue color precipitate, right? So the copper 2 from the salt will combine with the hydroxide from either the sodium hydroxide or the ammonia, aqueous ammonia that we added in, and so it forms copper 2 hydroxide, which is a precipitate, right? Because it's insoluble, and so we can assume that automatically we know it's copper 2 ions forming, right? Now if your salt solution had iron 2 ions, right? So then you would add in your aqueous ammonia or sodium hydroxide. Either way, it produces gives in hydroxide ions, and that iron 2 will combine with the hydroxide to form iron 2 hydroxide, which is dirty green precipitate color, and that proves that again you have iron 2 ions present. Okay, all right, so let's actually, what am I doing? Okay, so okay, right? Then if you add your sodium hydroxide or aqueous ammonia and you get a brown color precipitate, that means it is, what is the precipitate form? The precipitate form is iron 3 hydroxide, proving there is iron 3 ions. All the others, almost all the others, most of the time, whenever you add an aqueous ammonia or sodium hydroxide solution to any salt solution, you will get a precipitate most of the time. However, most of the time it's going to be a white color precipitate, because most of the cations like aluminum hydroxide, lead, zinc, magnesium, calcium hydroxide, all of them form white precipitates. Only specific transition elements like iron 2, iron 3, copper 2, right? Only they form colored precipitates, right? So then for those, the narrowing down is not very much, right? Okay, you narrow it down to still quite a few ions, because many of them are white color. Okay, however, if there is no precipitate formed, then it definitely is one of 3 ions: sodium, potassium, and ammonium, the normal spark category. Yeah, so basically sodium, potassium, and ammonium, even if you mix it sodium, potassium, or ammonium salt, right, though they do contain these cations, when you mix it with either aqueous ammonia or sodium hydroxide solution, you will not get any metal hydroxide, because a metal hydroxide might be formed, but it is totally soluble, right? So no precipitate will be formed, right? It will be a solution and we cannot get a precipitate. We can only narrow it down to 3 different salts. Still better than white precipitate though, right? And then we will see what we do with this eventually, right? Okay, I hope you all understand this part. I'm going to now show you, right? Okay, so guys, everywhere I've done this, the line, right? Okay, I've just reminded myself at that section, go to the, I don't know what you call it, your mind map or whatever down here, right? And show you all what is happening, right? Okay, so I don't overshoot and then realize that, oh, okay, I need to go back, right? So if I've marked place, I just quickly went through and I did my usual, I'll mark, right? To make sure the class is a bit more smoother. Okay, so now let's see what we have learned so far. We have not learned this whole flowchart yet, right? We are now just at the beginning of this flowchart, right? So this is what's happening. Okay, we start with a particular, let's say you have a salt solution. You have no clue what is a cation in the salt solution. However, someone has given you, your teacher has given you the task of finding out, hey, what is the cation present in this particular solution. So what are you going to do? I told you there's 2 things we're going to use. You're going to use sodium hydroxide, which will produce give hydroxide ions. You will also use what? excess, then you will add the same sodium hydroxide in excess, right? And we will also use what? Ammonia solution, right? And then excess ammonia solution, right? So that's it, right? At the beginning, to do the major narrowing down, right? At the initial, sorry, not major, the initial narrowing down, we will use sodium hydroxide and aqueous ammonia, which is what we have learned so far. Okay, so let's see what we're going to do here. Okay, sorry, keep as much as possible in frame. So guys, what have we learned? We learned that if you don't know what's a cation, so it's an unknown cation solution, right? The first step we're going to do is we'll use sodium hydroxide. Okay, we'll add in sodium hydroxide. It'll give in hydroxide ions. Now, if the ion, the cation that is present in this unknown cation solution was either zinc, aluminium, lead, calcium, or magnesium, it will form a white color precipitate. Okay? If it is one from this, which is what we just learned, right? I told you, right? It forms a white color precipitate. If, right, it is from the transition element side. If it's copper 2, iron 2, or iron 3, then it will form a colored precipitate, where copper 2 will form a blue color precipitate, iron 2 will form a green color precipitate, dirty green you could say, and iron 3 would form a brown color precipitate. Okay, so this is just by putting sodium hydroxide, we can narrow it down, right, a little bit. You're not getting a final answer yet, but you're narrowing it down to a less number of ions, right? And then if you get no precipitate, then it's probably ammonium ions, right? Okay, it can be sodium, it could be potassium, or it could be ammonium. But since it's very rarely ever going to be sodium or potassium, we straight assume it's going to be an ammonium ion. So this is what we have learned so far, right? Okay, so we have narrowed it down to 3 different groups, right? But none of it is a confirmatory test. You might say, hey, ammonium is on its own here, so it's the only ion possibility, but no, it could also be sodium and potassium. So when it's no precipitate, we need to do a further test. We need to heat up and blah, blah, blah. We will come to all that later, but I'm just telling you so far what we have done is this much. Okay, so I hope you understand, right? If you don't understand, maybe rewind the video and replay it again, right? And then if you still don't understand, then that means you need to tell me and alert me about that. Okay, I'm always ready to help. Okay, so guys, so that's what we've learned so far. Okay, right? Okay, let's go up, sorry. Okay, right? So now we're going to go to number 6. Okay, further narrowing down. So number 6. Aluminium, lead, and zinc ions form metal hydroxides, which are white precipitates, right? However, these white precipitates are soluble in excess sodium hydroxide solution, right? And then, if you want to further narrow it down, you can add zinc, if you look at zinc hydroxide, it will also be soluble in excess aqueous ammonia solution. So let's go to this and see what are they talking about. Okay, we're talking about this side of it, right? Forget everything else. We are looking at this, right? That means you had your unknown cation solution. You added sodium hydroxide. We are coming down this direction, right? And we got white color precipitate. So we know, oh, it's not this direction. It's not this direction. We are now in this pathway because white color precipitate. Then what did we do? Then now they told us, right? Okay, if you get this and if you add excess, that means if from your unknown cation solution, you don't just add sodium hydroxide, you add it in excess. Then what happens? You will find that if the precipitate dissolves, you have already narrowed it down to what? Either zinc, aluminium, or lead ions. Alright, so that is what. So now we've come in this pathway, we've come here, and it dissolved. So if it dissolved, we have come here, right? So we took our unknown cation solution, right? And we didn't just add sodium hydroxide, okay? We added sodium hydroxide straight away in excess, right? And we added it in excess. This white precipitate that was formed earlier, it dissolved, right? And that means, oh, if it dissolved, it became a solution. We know now, oh, that means we have narrowed it down to zinc, aluminium, or lead cations. All right, so this narrowing down has been done. And then they said, okay, if you have narrowed it down to this, you can further narrow it down further because, right, if it is zinc ions, it will dissolve in aqueous ammonia solution, excess aqueous ammonia solution. And if it's not zinc ions, if it's aluminium or lead, it will not dissolve, right? Okay, the precipitate will remain, right? So how do we test this? So you see this line here? I'm teaching you all how to use this flow chart, okay? Oops. Right? So I'm going to teach you all how to use flow chart. Every time you see a dotted, let me take off. Okay guys, every time you see, every time you see a dotted line like this, okay, that means we are starting with a brand new solution. That means we are going back to this step, taking a brand new solution and starting the experiment again. That's what a dotted line means, okay? If they didn't dot the line, for instance, can I see somewhere where they didn't dot the line? Okay, right? Okay, guys, they've always started with a new cation solution, okay, right? Okay, so but the point is, you need to understand, every time the line is dotted, we are taking back the original cation solution and starting the experiment again, right? Okay, so there we are. So now, let's continue from where we stopped. So again, just making sure we didn't just add excess ammonia and get white add sodium hydroxide and get white precipitate. We added excess sodium hydroxide and we still got that white precipitate, and then what happened? It totally dissolved. So we knew we had zinc, aluminium or lead ions, right? Now we took, so now we can narrow it down further because we know zinc ions are soluble in aqueous ammonia. So take a brand new solution, add excess aqueous ammonia, and if it dissolves, right, if the white precipitate dissolves, now we know, hey, that means it is zinc ions. And that's the confirmatory test, right? You have just confirmed that the only possible cation in that solution is zinc ions, Zn2 positive ions, right? However, right, let's rewind a little bit, okay? However, we did the same experiment and we find that yes, the ions are zinc, aluminium and lead. So we again took a brand new solution and we added excess ammonia, but this time something else happened. The white precipitate did not dissolve, right? So we narrowed it down to zinc, aluminium and lead, but the white precipitate didn't dissolve in excess aqueous ammonia solution. So we now know, hey, that means it is not zinc ions. If it's not zinc ions, what have we done? We have now only eliminated zinc. So we know that now the ion is either aluminium or lead ions, right? So we have not confirmed the ion yet. All right, so in this case we have not confirmed it. If it is zinc, we confirmed it, right? If the precipitate dissolved, we know it's definitely zinc, but now it didn't dissolve, so now we know it's one of two. It's either aluminium or lead ions. How are we going to confirm it? Later we're going to do by adding a specific reagent, right? Okay, so again we are going to stop at this part. So right now we have done until here. All right, so I just want everyone to be very clear about what we are doing, okay? So I'm taking all this off now because we're going to test different pathways, okay? All right, so taking all that off. Now, let's move on. Where was I, I was at, there we go, right? Okay, so we are done with number 6. Now we're going to go to number 7, okay? Now, if you have magnesium or calcium ions, however, right, they will form metal hydroxides, which are white precipitates with sodium hydroxide. However, only magnesium ion will produce white precipitate with aqueous ammonia, right? So let's go back down. Now we're doing magnesium and calcium. Okay, let's see, So I'm going to make sure that everyone is clear. So again, guys, what we did, we have an unknown cation solution. No idea what the cation is in here. So what we do, we first add what? Sodium hydroxide. When we added sodium hydroxide, what did we get? We got white precipitate, okay? Then what did we do? We added, right? Oh yeah, guys, so you see here, it's not dotted, right? It's just a straight line. So it's a straight line with the same solution. You just add more sodium hydroxide. So we say you add excess sodium hydroxide solution, right? Earlier we got a white, we found that the precipitate dissolved. So that means it was zinc, aluminium or lead. We were going in this direction, right? But now we are done with that already. Now we find that when we add excess sodium hydroxide, the precipitate did not dissolve. This white precipitate that was here remained there. The precipitate did not dissolve. White color precipitate still present. Then we can already summarize, so it's not zinc, aluminium or lead like earlier. That means the only two ions left, if it's not zinc, aluminium or lead, so we cancel off zinc, aluminium, lead. The only two ions are present is what? Calcium and magnesium. So we bring that down here. So now we know it's either calcium or magnesium, right? So that's what we have done. And then what they told us there is, okay, now from here you need to know, right, both calcium and magnesium hydroxide do not dissolve, right? And that's why we have this right here. But when you add, if you want to further narrow it down for calcium and magnesium, now you take a brand new solution and you add what? Excess ammonia, right? If you add excess ammonia, only calcium hydroxide will dissolve in excess ammonia. Magnesium hydroxide will not dissolve in excess ammonia. So that's the pathway we are taking, right? So let's say now I took a brand new solution, I added excess ammonia, and the white precipitate, the earlier white precipitate that was normally formed, right, now dissolves. So what happens? We know, oh, it dissolved. That means there is no precipitate, and that means it is calcium hydroxide. So there is calcium ions present in that salt solution. Or, for instance, if you added the excess ammonia, right, in this new solution, and what happened? The white precipitate stays, is formed, and it just stays, right? It doesn't dissolve, right? That means what? That means you are now having magnesium ions. It's really thick, man. Okay. Ready? Okay, so then, so like I said, then if you have a white precipitate that is formed with excess ammonia, that means it didn't dissolve. Only calcium hydroxide dissolves, okay, in excess aqueous ammonia. If it's magnesium hydroxide, it will not dissolve. So then you have narrowed it down, right? So either way, guys, whether you went down that path or you went down this path, you have already confirmed for magnesium and calcium. And also don't forget, earlier we came down this path and we also confirmed for zinc. So we've done all that confirmatory. So basically zinc, magnesium and calcium, there is no real confirmatory test, but by doing this observations and seeing whether they are precipitate dissolves or not, you can practically reach a conclusion, right, that is the only ion possible, right? But for aluminium or lead, when we came down this side, this pathway, when we found aluminium or lead, we have still not narrowed it down further. So if it's not narrowed down, we'll put it maybe in red color, so it's not finished yet, right? Okay, so we still need to work on it. So for the ions that don't get narrowed down, we will later add a specific reagent, right, to differentiate. So for aluminium and lead, we will add something later, chemical later, to differentiate between which is aluminium and which is lead, right? Okay, and finally narrow it down, right? But now I hope you'll understand what we have done so far. Okay. Okay, guys, right? I'll take all this off. We don't need it. Okay, done. Okay, now we can go to number 8, right? If you look at number 8, they said ammonium ions do not produce any precipitate with sodium hydroxide or aqueous ammonia solution. So if it's ammonium ions, guys, whether you add sodium hydroxide, whether you add aqueous ammonia, whether you add them in excess, you don't add them in excess, it really doesn't matter. Because if it is ammonium ions present, it will not form a precipitate. And we can prove that. Okay? Right? If you heat, where was I? Okay, you can prove it right here. So basically here, right? Okay, we took our unknown solution, we added sodium hydroxide and nothing formed. So we know no precipitate. So now we are guessing it is ammonium, but don't forget it could be sodium or potassium normally, right? It can also be, but most of the time it is never these. So normally we just say it's most probably ammonium, but because we can't say it 100%, we can't confirm it 100% as ammonium, right? The next part in number 8, they're going to tell you. Then what you can do, you can try to heat up the solution, and if it gives off a gas which turns red litmus paper to blue, that means you know it is ammonia gas. And if it's ammonia gas that is evolved, that means guaranteed it is ammonium ions. Okay. However, to double test ammonium ions, there is another reagent we can use, but we will see that later. Right now, we are not learning that part yet. Okay, so now this one we have done until here. Okay, so number 8, I've taught you about the part where if you add sodium hydroxide, in excess, you will get no precipitate. We are going to learn read the second part of number 8, which will tell you then you heat it up and then you will get a gas that changes red litmus paper to blue, which is ammonia gas, and that means again it confirms ammonium ions. Okay, but we will come to that. So the second part of number 8, guys, right? However, if a mixture of ammonium ion and sodium hydroxide is heated up, ammonia gas will be produced, right? Okay, and this ammonia gas that is produced, what did we say we will do? We will test it with a red litmus paper, and the damp red litmus paper, and it will change to blue color. And if it changes to blue color, we have proven ammonium ions are present. But still, there's a reagent that can test and tell you 100%, give a confirmatory test that it is ammonium ions, okay, which we will do later. Okay, now we're not at the confirmatory test part yet, okay, but we've done till number 8 completely, right? Let's go to number 9. Okay, number 9, they said, now if you add sodium hydroxide solution, you will get two transition elements like copper, iron 2 and iron 3 hydroxide. Then they will form copper 2 hydroxide, iron 2 hydroxide and iron 3 hydroxide, right? Okay, so you add sodium hydroxide to your salt solution, you will get copper 2, iron 2 or iron 3 hydroxide, and they all have their own specific colors, right? And they said it will not dissolve in excess sodium hydroxide solution. However, copper 2 hydroxide will dissolve in excess aqueous ammonia to form a dark blue solution. Only copper 2 hydroxide. So let's have a look at that. I'm sorry, it's a lot of going up and down because I want you all to understand exactly what is happening. So they said, now what happens? We added sodium hydroxide like earlier. Now what happened is we got a colored precipitate. Okay, if you got a colored precipitate, right, and if it was blue, we already did earlier, right, it'll be copper 2. If it's green, it's iron 2. If it's brown, it is iron 3 hydroxide, right? So we know those ions are present, right? So anyway, if that is the case, right, they're just telling you that we can, so now you know it's either you know which one it is, right? But if you want to just double check to make sure everything is okay, you now take a brand new solution. See this dotted line? Take a brand new solution from the top, and now you add what? Aqueous ammonia. Not in excess, just add aqueous ammonia. Again, you will get the same results. Okay, blue, green, brown, copper 2, iron 2, iron 3. But what you need to do is, you added ammonia, right? Now add it in excess, right? Especially if you got a blue color precipitate, add it in excess. If it's a blue color precipitate, then probably it's copper 2 ions, right? So now when you add aqueous ammonia in excess, that blue color precipitate will dissolve and form a dark blue solution, confirming definitely what was the precipitate formed earlier was copper 2 hydroxide, and that means it dissolved and formed the copper 2 hydroxide dissolved and formed a dark blue solution with excess ammonia, right? And that means if that was definitely copper 2 hydroxide, that means copper 2 ions are present, and that confirms the presence of Cu2 positive ions. Okay, and the thing is, if when you added the aqueous ammonia, right, you got green or brown solution, well, then you need to do a confirmatory test. Okay, the confirmatory test, we will talk about it later. Okay, so even here for copper 2, we have already confirmed it, nothing to worry about. So basically, what have you confirmed so far? Zinc, magnesium, calcium, copper 2. These are the ones we have reached the end already. We have already come to the end of them. We found it. If you come to that pathway and you get it, that is the confirmatory test, right? But you came to the conclusion by narrowing down, not by using a specific reagent. Okay, all right. So, okay, bear with me, guys. Okay, it's a lot of moving up and down. I'm sorry. Okay, all right. Okay, so I've done number 8 with you. I've done number 9 with you, right? Okay, now guys, they're telling you whatever we learned from number 1 to number 9 there has been summarized in a table for you. And that table is table 8.20. Now, if you ask me, and if you really understood, if I was going too fast, please go back, play the video back again. That's the good part about this, right? You can play it back again at your leisure and understand what we just said, right? You wouldn't even need this table. But however, if you did understand it, right, and you want to double check, please feel free to go through this table. It just tells you, right, what happens, all the different ions, and what happens when you mix them with either sodium hydroxide solution or aqueous ammonia solution. And then what happens when you put excess sodium hydroxide solution and excess aqueous ammonia solution. So that's it, right? Okay, what color precipitate it forms? Does it form a precipitate? Doesn't form a precipitate, right? Does the precipitate dissolve when do we put in excess or not? All those things, right, which we've already done, right? It will tell you here, okay? But what I'm not going to do is, because we've already kind of learned it, now I'll be just repeating a lot of words again, and it'll just make it very confusing. So I am not going to do this table 8.2 with you. I think it will be counterproductive for this video. However, if you are doing a revision and you want to go through this table, you're more than welcome to go through it. And if any part of it you don't understand, you can definitely ask me about it, okay? Okay. So that's this table. Now, guys, okay, so we have reached a certain point, right? Okay, not everything we could confirm. We managed to confirm zinc. We managed to confirm where is it, right? Okay, guys, again, I'm sorry, I'm repeating. We managed to confirm zinc. We managed to confirm magnesium. We managed to confirm calcium. We managed to confirm copper too. But we have a problem, right? Some of them are still unconfirmed, right? We have narrowed it down, but not enough, right? Aluminium and lead, we have not confirmed yet. Okay, then on this side done. Okay, right? Iron 2 we have not confirmed yet. Iron 3 we have not confirmed yet. Even ammonium we have not confirmed yet. So we are stuck at this places. So when sodium hydroxide and aqueous ammonia can't help you confirm something, at that point we will resort to using specific reagents like here we have, right? Potassium iodide, potassium hexocyanophrate 3, so on and so forth. We will have to use special reagents to help us narrow down, right, for these particular ions. The rest we could do it with just ammonia and sodium hydroxide. But for this, guys, sorry lah, okay, ammonia and sodium hydroxide could only bring it down to a few, and we to confirm which one it is, we have to do a confirmatory test with a specific reagent, or what is known as a chemical. So let's go to that part. Okay, now we don't have to go up and down so much already. It's already one page away. So that is kind of good. Please give me a second to drink a bit of water. Okay. Okay, guys. So now we go all the way to the end. Okay, we're already at the end of the whole thing. Okay. Now, so we do have a problem. We couldn't confirm Fe2 positive, Fe3 positive, ammonium and lead and aluminium ions, right? There is no confirmatory test for aluminium ion. So for us, it's simple. If we are torn up between two, right? We are not sure whether it's aluminium or lead. But since there's a confirmatory test for lead, right? The moment you can confirm it is lead ion, then it just proves it's not aluminium ion. If you can't confirm it's lead ion, then you know, oh, that means it is aluminium ion. But for the others, there is a full confirmatory test. Iron 2, Iron 3, ammonium, there are specific reagents that will confirm it perfectly for us. All right, let's start with this last part of this chapter. Okay, all right, guys. So let's go to number 1. Okay, you're going to learn about different names of different reagents, right? Okay, it's just a name. Okay, just bear with me, right? Okay, so number 1, potassium hexocyanophrate 2, right? And the chemical formula is there, K4Fe, right? Cyano group, so CN6, right? Okay, so we call it potassium hexocyanophrate 2, solution. Potassium hexocyanophrate 3 solution, it's exactly the same thing, guys. Just that potassium hexocyanophrate 2 is K4. Oops, it's blocking the 4. Right, is K4, whereas potassium hexocyanophrate 3 is K3. So just remember that if it's 3, then it's K3. And if it is 2, then it won't follow, right? So K4 is potassium hexocyanophrate 2, and K3 is potassium hexocyanophrate 3. Okay? Alright, so, alright, I'll read again. So potassium hexocyanophrate 2 and hexocyanophrate 3 solution, even another solution known as potassium thiocyanate, which is labeled as KSCN, right? These are all reagents and can be used to confirm the presence of Fe2 positive and Fe3 positive ions as shown in the table below. So let's see this, right? Okay, so let's say I am suspecting I have Fe2 positive ions. Why would I be suspecting Fe2 positive ions? When I put sodium hydroxide, I got a green color precipitate. So when I got a green color precipitate, I'm already suspecting it's Fe2 positive. I want to make sure that I get it perfectly correct. I want to do a confirmatory test since a reagent is available for Fe2 positive. So I can choose between 3 reagents. Potassium hexocyanophrate 2, then potassium hexocyanophrate 3, and right, we've not gone through this yet up there in the wordings, but we will go there eventually. You can even add acidified potassium manganate 7 solution, right? And it's very simple. If you're using potassium hexocyanophrate 2 and it mixes with the iron 2 ions, it'll form a light blue precipitate. If you add in potassium hexacyanophrate 3 that reacts with the iron 2 ions, it'll form a dark blue or a Prussian blue precipitate, right? If you're using acidified potassium manganate 7 solution and you put it into any salt solution with iron 2 ions, it will decolorize the purple color. So acidified potassium manganate 7 is purple. You add it with iron 2, it'll decolorize and become colorless. And you see, so that is the 3 tests we can do for iron 2 ions. However, guys, right, in your book, they are using, because they can't, it's a flow chart, right? So they can't put all 3 there, it'll become very confusing. So they have chosen the most common one and the easiest one to use is normally this guy right here. They chose to use potassium hexacyanophrate 3, right? And they will get a dark blue precipitate. So we're going to go and see that, right? So again, we were torn here. Okay, we came down this path, right? And here we for copper we managed to confirm, but here we got green for iron 2. We didn't have a confirmatory test, so all you do is take a brand new solution right from the top, and what do? We add potassium hexacyanophrate 3, right? There's a 3 there, so that's potassium hexacyanophrate 3, and if it forms this dark blue precipitate, then it confirms iron 2 ions are present. And with that, guys, we have just done the confirmatory test for Fe2 positive. Again, right, you don't have to add potassium hexacyanophrate 3. That's just what your book added in, right? Okay, that's what the book used, right? But you also could use potassium hexacyanophrate 2 to get a light blue precipitate, or you could use acidified potassium manganate 7 and if it'll get decolorized from purple to colorless, and those are also possible confirmatory reagents that you can use. Okay, but I will just do this right for the one that was used in the flow chart. All right, so it is clear. All right, let's go to the next one. If there is iron 3 ions, right? So you have iron 3 ions, then you have few things you can use, right? Potassium thiocyanate, this solution, you just mix it with the original salt solution if it forms blood red color. Now, why did I use potassium thiocyanate? Because I already did my earlier experiment, and we added sodium hydroxide or aqueous ammonia, and what did we get? We got a brown color precipitate. If it is a brown color precipitate, we are already suspecting iron 3 ions. So now you're suspecting iron 3 ions, you can use any one of these 3 reagents. So again, if you use potassium thiocyanate, it gives a blood red color. This is a very nice test because the color is so different. It is not light blue, dark blue like the earlier one, right? Very close. This is a blood red color. You will never get it with any other solution. So it's a nice one. You will never make a mistake, right? Blood red is drastically different color. So when you add potassium thiocyanate and you get that blood red color, you know definitely it's iron 3 ions are present. However, if you don't want to use the most obvious one here, we can still use the other 2 reagents that can also test for Fe2 positive, like I said earlier, right? In this case, you can use potassium hexacyanophrate 2, this guy, right? And what happens if there's iron 3 ions there, it will form a turn blue, bull blue, right? Earlier was Prussian blue for Fe2 positive, now it's turn bull blue for Fe3 positive, right? Okay, and again, yeah, so it will form a precipitate. Again, dark blue, right? Precipitate. If you use potassium hexacyanophrate 3, it'll form a greenish brown solution, right? Again, I say the best one, right, is which one? And the one the one that is used in the book is this guy right here, potassium thiocyanate solution, right? So potassium thiocyanate solution gives a blood red color. Let's double check, right? So we have come till here, right? We have a brown precipitate, so we are suspecting iron 3 ions. Then you take a brand new solution because of the dotted lines. You take a brand new solution and you add potassium thiocyanate, and guess what? You get a blood red color, right? Definitely confirming, yes guys, it's iron 3 ions present. Okay, so with that we have now confirmed even iron 3 ions. Okay, all right, okay, so done. That is so done. All right, oops, I pressed undo and took this off. Okay, let's move on. Now number 2, they're talking about potassium manganate 7 solution acidified. So we've already done that with you. We straight go here to number 3. Okay, what about lead ion? So guys, just here we will cancel off the ones that we have finalized already. Iron 2 done, iron 3 done. Okay, we've confirmed them fully. Okay, let's go to number 3. Lead-2 ions can be confirmed by adding an iodide solution. For example, you can add what? Potassium iodide. Up to you. You want to add sodium iodide, magnesium iodide, whatever lah, right? Okay. As long as you add an iodide solution, you can test for Pb2 ions because, right, when lead ions mix with iodide ions, it will form lead iodide, and lead iodide is an insoluble form. Insoluble salt, sorry, and that insoluble salt will form a yellow precipitate. Okay, or they said if you don't want to add a iodide solution, you could add a what solution? You could add a chloride solution. If you add a chloride solution like sodium chloride, potassium chloride, okay, calcium chloride, really doesn't matter, right? But as long as you add a chloride solution, it will provide these chloride ions, and so the lead in the salt will react with the chloride ions to form lead-2 chloride. And again, lead-2 chloride, if you memorize your soluble and insoluble salts, you will know it's an insoluble salt which will form a white precipitate. So you see, you can even test with that. Okay, and then if you don't want to use a chloride salt, then you can just use another reaction to form an insoluble salt. So in this case, you can add any sulfate solution to provide the sulfate ions, right? Okay, so when you add a sulfate solution, right, the lead in our salt will react with that sulfate, with that sulfate ions, and it will form lead sulfate. And as you know, lead sulfate, again an insoluble salt that forms a white color precipitate. Okay, so in other words, in all three of these reactions here, I think this pen is getting worn off, right? So in all these three reactions, A, B, C here, right, okay, all of it formed insoluble salt. In other words, all these three reactions is just a type of what? Double decomposition reaction to form an insoluble salt. And in the process, I help you identify whether lead ions are present, because lead iodide, lead chloride, and lead sulfate, they are all insoluble salts. Okay, and there you go, right? So that will be the confirmatory tests for lead. So anyway, we're not done. We can go down here and we can actually see what can we do. So again, we have lead-2 ions, right? You could add any iodide solution like potassium iodide or sodium iodide, okay, and it'll form a yellow precipitate of lead iodide, right? Now the beauty of this lead iodide, you can double check it, because this yellow precipitate, if ever it's in lead iodide form, right, it is always soluble in hot water. That means you heat it up and it becomes a solution. You cool it down, it'll recrystallize, right, and it'll form crystals. Okay, it'll form salt crystals when it cools down. Then you heat it up again, it will dissolve. Cool it down, again, it'll recrystallize. So that is why I would say the iodide is the best test, right? Okay, but for the other two, whether you're adding any of the chloride solutions or any of the sulfate solutions to form lead chloride or lead iodide, which is both white precipitates, right? So those are less obvious because this is white, okay? But anyway, for the chloride one, it's the same thing. It is soluble in hot water but recrystallize in cold when it is cooled down. However, for sulfate, it is a white precipitate that is just insoluble. Whether in hot water or cold water, it will remain as a precipitate. It never dissolves at all, right? So the best is this because there's a color difference, right? The second best would be this because it still shows soluble in hot and cold water. It's same, these two. Okay. Sorry guys, okay, so alright, okay, so these two, right, are the best to use, right, because both of them are soluble in hot water and they'll recrystallize when cool. However, this is the best because why? You can get a nice yellow color precipitate. It's a double confirmation, and if you can't do this two, only then as a last resort we will use the third one, sulfate, because it's white precipitate, right? And you can't test it based on whether it's soluble in hot or cold water, because either way it is insoluble. It just remain as a precipitate. So obviously, like I said, the first one is the best. So your book has used potassium iodide, if I'm not mistaken, right? And we can prove it right here. So again, earlier we were stuck where we managed to narrow it down to aluminium or lead. What do? We add now what I said earlier, potassium iodide, and if no precipitate is formed, that means you say that means it's not lead. And if it's not lead, so we can cancel off lead, that means the only thing left is aluminium. So that is by deduction, right? However, if a yellow precipitate forms, right, then we know definitely lead 2 ions are present. Okay, and so that's how we go, because there's no real test for aluminium ions, right? So whether it's aluminium or not, even if you suspect it's aluminium, you still have to do a test for lead to confirm that it's not lead, and in turn it proves that it is aluminium ions. Okay, right? I hope you all are still following, right? I told you it's not hard, but it just gets a bit confusing. All right, so we are done with everything, and so from that we can even solve. We can even cancel off what we have also found: lead 2 ions. Okay, what does that leave us with? Ammonium ions. But ammonium ions, super easy, right? We come down here. Look at number 5, right? So number 5. Nessler's reagent, right? It's a special reagent to test the presence of ammonium ions. This reagent forms a brown precipitate with ammonium ions. So ammonium, super easy, right? Basically, this is what happened. You added sodium hydroxide solution, you got no precipitate. Oh, you're already suspecting ammonium ions, no precipitate, right? Then you to double check, you heated it. Took the original solution and you heated it up. When you heated it up, it let out a gas, right? We wanted to prove it's ammonia gas, so what do? We tested with red litmus paper, and the red litmus paper turned blue, right? And ammonia gas is the only alkali gas. So automatically that again says, okay, that means it is most probably ammonium. But again, it's not a confirmatory test until you use the reagent which we just learned. So you take a brand new solution. Now we add the reagent we just said, right? Add Nessler's reagent. And if it forms a brown precipitate, guaranteed ammonium ions are formed. Okay, that means ammonium ions are present. Okay, so as simple as that. And with that, let's just check, have we confirmed everything, right? Yes, we confirmed zinc earlier, right? We just we came to this point where we were not sure whether it's aluminium or it's lead, but then after doing the confirmatory test of this, right, we even managed to confirm aluminium and lead, right? So that also is done. Then at the beginning itself, we managed to confirm magnesium and calcium ions, right? And then again at the beginning, we managed to confirm even copper ions. And then after adding the reagent, we managed to confirm Fe3 positive and Fe2 positive ions. Finally, we had ammonia, which we tested, okay, with Nessler's reagent, and we confirmed ammonium ions as well. And with that, right, so basically this has been already corrected. So we take off this, okay, take this off, and what do we have? Let's see, anything not solved, confirmed, 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 all confirmed, and we are done with the cation tests. Okay, so all the cation tests fully done. If you'll have any questions, okay, and this is the one that was used in the book, it was the only one, but anyway, I'll just complete everything up, right? And with that, we can also cancel off ammonium, right? All have been done, right? Okay. Okay, all right, guys. Oops, sorry. Okay. All right, so now that leaves us with the last one here. Okay, so we are done with cation tests. Okay, all the cation tests are done. For some reason, my screen recording app is stopped working. It always does that. I don't know why, but it's still recording. I'm very sure. Okay. All right. So anyway, bear with me. So now we can go to the next one. Flow chart for the analysis of anions. This one very easy. We're practically done with it, right? So at the beginning of the 8.2, we learned that if you heat up a particular salt solution, you do a heating test, right? We can see what happens. And if you heat it up, okay, if you heat it up, okay, just ignore the screen recording thing. All right, so if you heat it up and it releases I'm circling wrong. It releases carbon dioxide gas. We already think there's carbonate ions. However, we want a confirmatory test for carbonate ions. What do you do with a confirmatory test for carbonate ions, right? You take a brand new solution, right? See this dotted line? So that says take a brand new solution, right? And you add a dilute acid. And still, if it turns lime water cloudy and carbon dioxide gas is released, that is the confirmatory test that carbonate ions are produced, right? Okay. Right. The next one, let's say you have or you heat up a solid, sorry, right, and then it produces a gas that rekindles a glowing splinter. That means you can confirm that is probably oxygen gas, or a brown color gas, and that is nitrogen dioxide gas. You can come to the kind of a conclusion, right? Or at least you can suspect definitely nitrate ions are involved. So if that's the case, then you have to do the confirmatory test for nitrate ions, right? Which I've done with you in the previous video. It is the brown ring test, okay? Where you add a dilute sulfuric acid, then you add a bit of iron sulfate, and then you drop concentrated sulfuric acid by the side of the test tube, and it should form a brown ring in the middle, and that will prove that nitrate ions are present. Right? And then next one, you heat the solid, right, and it produces sulfur dioxide gas or sulfur trioxide gas. Either of these gases will decolorize potassium manganate, acidified potassium manganate 7 solution. So if that happens, you're already suspecting it's sulfate ions. Then you do the test for sulfate ions, right? Okay, and then what is it? You add sodium nitrate, and then you add barium nitrate. Barium nitrate will react with the sulfate ions to form barium sulfate. Barium sulfate is a white precipitate that confirms sulfate ions are present. I don't even need to do this section, guys, because I did it in the last video. It's a test for anions, right? Okay, but anyway, let me just finish it nicely for you all. And finally, if you heat up your solid, right, and no gas is evolved, that's because it's probably a very stable sulfate or a very stable chloride salt, so it doesn't give off any gas. So now we know it's either we don't know, we're suspecting it's either sulfate or chloride. Okay, so what do? Well, you just do the same sulfate test on it. You add nitric acid, and then you add barium nitrate. If it forms a white precipitate, then you know it's a sulfate salt, right? However, if no precipitate is formed, then it is not a sulfate salt. So then what do? You know it's not sulfate, so you need to do the test for what? Chloride. So what's the chloride test again? Simple. You add nitric acid, and then you add silver nitrate, and then it will the silver will react with the chloride and form silver chloride, and silver chloride is a white precipitate, and that will prove that chloride ions are present. Okay, guys. So with that, right, we have done the whole chapter, whole second part, the harder part of the chapter, the qualitative analysis, which is the hard part. Everything else is just calculations, right, which is what you've learned from chapter 3, form 4. But everything else we've already covered, and this should put you in solid position to answer questions on salts. Okay, and it's done in a video form. I hope it's helpful. Even before the exam or whatever, you can actually go through this and make sure you understand what's happening. Okay, all right, guys. So with that, I think I'll end the class here. My recording app is anyway giving a bit of trouble, but anyway, so yeah, so we will end the class here. If you have any questions, please don't hesitate to let me know. All right, thank you very much. Okay, thank you.